Good evening, guys, because I think you're watching this in the evening. Good morning if you're watching it in the morning. Today we'll talk about dividing polynomials and are continuing on Unit 3, Polynomial and Rational Functions. Now, in some books, this is called the remainder theorem. And yeah, just in case you come across books that call it that, it's the same thing as long division with polynomials. Just a recap of long division back in third grade. 7 divided by 2 was a simple thing. You just ask yourself, how many times does 2 go into 7? That's 3. 3 times 2 is 6. And then when you subtract, you have a remainder of 1. So this was the divisor. This was the remainder, is the remainder. And this is the dividend. And that is the quotient. So we're going to do the same exact thing with polynomial expression, the same exact thing. So what we're doing is trying to divide this whole expression, that polynomial function, using this factor or using this divisor. So I'll write it out: x plus 2, long division, that's not a square root, it's just long division, 2x cubed, 3x squared, 4x, 5. Now I'll only be using the variable terms to divide with the variable terms. Let me just show you. So I'll start by trying to figure out what is 2x cubed divided by x. 2x cubed divided by x is simply 2x squared. I'm not going to go and do 2x cubed divided by 2, because if I do that, I'll end up with x cubed at the top here, which goes against division, because when I divide, I expect to get a smaller degree than what the initial polynomial was. So that's why we don't use that for constant terms. So we only divide using the variable terms. So 2x cubed divided by x is 2x squared. Now, coming back, 2x squared times x gives me 2x cubed. And now I'm going to use this term, the constant term. 2x squared times 2 is giving me a positive, because it's positive 2. 2x squared times positive 2 is positive 4x squared. At this stage, I can subtract. 2x cubed minus 2x cubed is 0. Negative 3x squared minus positive 4x squared, that is negative 7x squared. So at this stage, I can bring this down. That's a positive 4x and a positive 5. And then repeat the process. So now 7x squared divided by, negative 7x squared divided by x, that's going to give me a negative 7x. Then do the reverse. 7x, negative 7x times x gives you negative 7x squared, and negative 7x times positive 2 gives you negative 14x. So long division of polynomials is another way of factoring polynomials. These were able to come down because technically you have a 0 here and a 0 here, and when you subtract positive 4x minus 0, you still end up with positive 4x. 5 minus 0 is still 5. So 7x squared minus 7x squared, that's a 0. Positive 4x minus negative 14x, that's a positive 18x. And then down here, I can just drop it down, or I can assume I have a 0 and say 5 minus 0 is a positive 5. Looks like I'm getting closer and closer to a remainder, because I'll stop dividing when I no longer have an x term in this area. So this is probably going to be the last one. 18x divided by x is positive 18. Then do the reverse. 18 times x is 18x, and 18 times 2 is positive 36. Do the subtraction. 18x minus 18x gives you 0, and 5 minus 36 gives you negative 31. So remember, just like in long division, negative 31 is my remainder. x plus 2 is my divisor, and this whole term at the top is my quotient, and the expression that I started with is the dividend. So just a reminder, remember when we did 7 divided by 2, we got 3, remainder 1, right? So 7 can be written as 7 divided by can be written as 3 times 2 plus 1. Can be written as 3 times 2 plus 1, which is the remainder. That's one way I can write 7. So just thinking of how can I write this expression here, I can write this expression as the divisor times the dividend plus the remainder, which is negative 31. I hope that makes sense. The divisor plus the dividend minus 31. That's one way I can write this whole expression. Now, I told you at some point that this is a way of factoring polynomials. It is very useful when factoring if the polynomial has if it is factorable, but the fact that we have a remainder that is not 0 tells you that this one is not completely factorable. Just pause this for a little bit. Another way I can write what's happening here is that 7 divided by 2 is the same thing as 3 plus 1 over 2. Because I know 7 divided by 2 is 3.5, and on this side I also have 3 plus a half, which is 3 plus 0.5, which is 3.5. So what I'm trying to show you is that the dividend out of the divisor is equal to the quotient plus the remainder out of the divisor. Now, using this idea, I can rewrite this expression here. In both of those ways. I can say either the whole expression that I started with, needs a different color. The whole expression that I started with could be written as, so let me just call this fx because it's big and I don't want to write it all over again. Let me just call it fx. F of x can be written as the quotient, which is 2x squared minus 7x plus 18 times, because remember 7 is equal to 3 times 2, so times the divisor, which is x plus 2, plus the remainder, which is minus 31. That's one way I can write this whole expression. And if you expand this out, it will give you the same fx again. Or I can write it as, I can say fx over x plus 2 is the same thing as the quotient, 2x squared minus 7x plus 18 plus the remainder divided by the divisor. But the remainder was negative 31, so it's a negative 31 divided by x plus 2. I hope this makes sense. And just to make it easier for you, let me just write the 7 out of 2 thing again. Remember, 7 out of 2 is either 3, which was the quotient, plus a half, or I can write the thing as 7 is equal to 3 times 2 plus the remainder, which was 1. This second notation is what I wrote here first, this one here, and this first one is what I wrote in this section here. So this is what we're going to be doing with most polynomials in order to factor them. One of the questions on your quiz from Wednesday, you weren't able to factorize it because you hadn't yet been taught this, but now you have. And last time you did it, you used the graphing calculator, but in the future you'll be asked to not use a graphing calculator and still be able to factorize it in this way to find a solution. So just a recap, write it out like this. Put the x plus 2 there, the 2x cubed. First step is divide 2x cubed by x, you get 2x squared. Then do the reverse by multiplying. 2x squared times x is 2x cubed. 2x squared times 2 is 2x squared times 2 is 4x squared, positive 4x squared. Then what you do is subtract and follow the process, and you end up getting the same thing. So just a reminder, that's the dividend and that's the divider. The top is the quotient. What you have left is the remainder. So this is what I was telling you earlier. You can write it like this. It can be written like this, that the whole expression fx divided by x plus 2 is the same thing as 2x squared minus 7x plus 18 minus 31 divided by the quotient. And the other way to write it is this whole thing, 2x squared, remember I called it fx, is equal to 2x squared minus 7x plus 18 times x plus 2 plus the remainder, which is 31. I hope you can see that if we didn't have a remainder, then we would have factored this expression, because this is a factored form of the expression. We have already taken out one factor, one linear factor, and we can use our knowledge of factoring quadratics to factorize this expression. Let's look at another example. I want to use long division to divide x cubed minus 126 by x minus 5. So x cubed minus 126, divide that by x minus 5. Start by dividing x cubed divided by x. That gives you x squared. Use a different color, red, for the quotient, x squared. And then x squared times x, that takes you back to x cubed. I hope you remember that, x cubed. X squared times negative 5 is negative 5x squared. Subtract. X cubed minus x cubed is 0. This is not a squared term, so the squared factor of this equation is 0. This equation is basically, if I were to write it here, just give me a minute. If I were to rewrite it, I could write it as x cubed minus or plus 0x squared plus 0x, just showing you that it's square and linear terms are 0, and then finally minus 126, such that when I do the long division, it lines up for me nicely. I would have x squared there at the top, then this would be x cubed minus 5x squared. So when you do the subtraction, this is the exact same thing as this. I'm just showing you that the terms here are 0, so that you don't try to subtract 126 minus 5x squared. So x cubed minus x cubed is 0, and 0x squared minus negative 5x squared is positive 5x squared. And remember, this whole area can be filled in with zeros because nothing exists there. So when you subtract 0x minus 0, you get 0, and 126 minus 0, you still get negative 126. So then you continue the process. 5, so I'll just keep going from here, from this side. 5x squared divided by x is a positive 5x. 5x times x is 5x squared. And 5x times negative 5 is negative 25x. Just reminding you that again, this area is, I'm going to write the 126 again. Just trying to remove, erase. Okay. It's the same thing as 5x squared minus 0x minus 126. Just writing that so that the subtraction can look, the visual can look better. So 5x squared minus 5x squared is 0. Negative 0x minus negative 25x, I hope you see, is a positive 25x. And remember, there's a 0 here, so negative 126 minus 0 is still negative 126. One more time, because I think that will be it. 25x divided by x is 25. That's a positive 25. And do the reverse. 25 times x is 25x. And 25 times 5 is 125, negative 125. So when I subtract, I can see 25x minus 25x is 0. Negative 126 minus negative 125 is negative 1. So I'm ending up with And this is the way that we prefer to write it in math. I'm ending up with the fact that x cubed minus 126 divided by x minus 5 is the same thing as, remember the quotient, which is x squared plus 5x plus 25 plus the remainder, which is negative 1, and the remainder is divided by the divisor, x minus 5. If this is confusing, just go back to the 7 divided by 2 example. Remember, 7 divided by 2 is 3 plus 1 divided by 2. This is 3.5, and this is also 3 plus 0.5, which is 3.5. So I'm just expressing this quotient or this fraction in this format. See another example. Use synthetic division. That's another thing that it's called, synthetic division, remainder theorem, long division, to divide 5x squared minus 3x minus 36 by x minus 3. So x minus 3, and you can feel free to either pause and try this on your own and see if you did it right, or you can just skip over it, see the answer in a couple of minutes, see if you did it right. Because if this was in class, I would be asking you to do this on your own, and I'll just be checking on you. All right, so let's try this one. 5x squared, remember, divided by x is 5x. 5x times x is 5x squared. 5x times negative 3 is negative 15x. Subtract. Remember, this is zeros here. 5x squared minus 5x squared is 0. Negative 3x minus negative 15x. Who knows the answer? Negative 3x minus negative 15x, that is a positive 12x. Negative 36 minus 0 is negative 36. 12x divided by x is a positive 12. Positive 12 times x is 12x. And positive 12 times 3 is, times negative 3 is negative 36. So 12x times minus 12x is 0. Negative 36 minus negative 36 is also 0. So this is the first time we don't have a remainder, and this means that we've been able to factorize this using that, divide this completely using that factor, and like I've told you before, it's one of the skills of factoring polynomials. So writing it in terms of completed division, it was 5x squared minus 3x minus 36 divided by x minus 3. That's equal to 5x plus 12. No remainder. If you want, it would have been plus the remainder divided by the divisor, but I don't have a remainder here, so it's just 5x plus 12 when you divide those two. This means that if you take 5x plus 12 and you multiply it by x minus 3, it should give you back this expression. And you can try this on your own to see if I am right. Use synthetic division, another one. Go ahead and pause if you want to try it on your own. But let me also go through this one. 9x to the power 4, 10x cubed, 7x squared minus 6. Divide that by x minus 1. X minus 1. Straight. There we go. So 9x to the power 4 divided by x is 9x to the power 3. Negative 9x to the power 3 times x is negative 9x to the power 4. Negative 9x to the power 3 times negative 1 is positive 9x to the power 3. Remember, this is 0, 0, because I didn't have any other terms to multiply this by. So then I'll subtract negative 9x minus negative 9x power 4 minus negative 9x power 4, that's a 0. 10x cubed minus 9x cubed, that's a positive x cubed. 7x squared minus, I don't have any other squared term, so that's just 7x squared. I hope you can see that after a squared term, the next natural term would be a linear term, but that's also 0. I'm putting there just so the next level will look simpler, or will look easier. Now x cubed divided by x is x squared, positive. X squared times x is x cubed. X squared times -1 is negative x squared. I have nothing else to multiply with, so these are zeros. Subtract x cubed minus x cubed is 0. 7x squared minus negative 7x squared, that's, 7x squared minus negative x squared, that's 8x squared. 0 minus 0 is 0, so I have 0x. And -6 minus 0 is -6. Keep going. So I'm dividing 8x squared by x. That gives me 8x. 8x times x is 8x squared plus, 8x squared times -1 is -8x. Since I'm not dividing by any other term or multiplying, that's a 0. It could be positive or negative. 8x squared minus 8x squared, 0. 0x minus -8x, positive 8x. -6 minus 0 is 0. Oh, sorry, -6. -6 minus 0 is -6. So 8x divided by x is positive 8. 8 times x, positive 8x. 8 times -1 is -8. Subtract, I'll end up with 0. -6 minus -8 is positive 2. So my remainder is 2, and I can rewrite my expression as, let me call this f of x again because I don't want to write the whole thing. I can write it as f of x divided by x minus 1 gives you this quotient, 9x cubed plus x squared, this is negative, plus 8x plus 8, then plus, just write it down here, plus 2 out of x minus 1. So that's my expression. Let me write it better here. -9x cubed, x squared, 8x, 8 plus 2 out of x minus 1. So that's what I get when I divide this whole expression fx by x minus 1. Alright, an application on graphs. It says use the graph of the third degree polynomial and one factor, so the key term is here, one factor, to write the factored form and the polynomials suggested by the graph. The factored form of the polynomial suggested by the graph. The leading coefficient is 1 and the factor is x squared minus x, and one of the factors is x squared minus x plus 3. So when I look at this graph, I hope you remember that this is one of the zeros. It's one of the zeros. X is equal to -1 is one of the zeros. And if x is -1 is a 0, that means, take the 1 over that way, that means x plus 1 is a factor. So I already know that x plus 1 is a factor because I've looked at the graph. And another factor is here. So what they want me to do is to write the factored form of the polynomial. Now, x plus 1 is one of the factors, so I have x plus 1. This x squared minus x plus 3 is also one of the factors, x squared minus x plus 3. Now this is my polynomial already. This is my polynomial. F of x is equal to that times that, x plus 1 times x squared minus x plus 3. But it's not completely factored because this is a quadratic equation that can be factored. And I hope you remember when I'm factoring this, I try to look for the factors of x squared, which is x times x. Try to look for the factors of 3. These ones really have to just be 3 and 1. And then I try to see how I can work with them to get a sum of -1. So what numbers here, how can I If this is a negative, do I get a sum of -1? No. If this is a negative, do I get a sum of -1? No. What does this mean? This means that this equation, this quadratic equation, is either has imaginary factors or that I'm going to have to complete squares. That's what I'm going to do. I'm going to complete squares on this one. If this was a 2, it would have been nice and easy, but it's not. Thank you, Miss Williams. So what I'll do here is I'm going to complete squares, and I hope you remember, take 1x. Let me use a different color on this. 1x, subtract half of the coefficient, so x minus half squared, and then subtract the square of that half, so minus a quarter, plus 3. Okay, so this is x plus 1. Now I'm only doing all of this because this quadratic section is just difficult to factorize. It's not impossible. It's not impossible. It just doesn't have factors, so I need to go this route. But if it was, just imagine it was 2, then it would be nice and simple, and you would just have your polynomial as f of x is equal to x plus 1 into the factors there would be x minus. If that was a 2, then the 3 would have to be negative. So x minus 3 into x plus 1. That's what it would be. You would be finished, and this is the kind that you're possibly going to have on your quizzes. But what we have here is x minus half squared and 3 minus a quarter. 3 minus a quarter is the same as 2 and 3/4. So it's plus 2 and 3/4. Two whole numbers and 3/4. Let me write that better. 2 whole numbers, 3/4. So still need to factorize it completely. So this is going to be x plus 1 into x minus 1 out of 2 squared minus, and stay with me here, minus 2 whole numbers, 3 out of 4 I squared. This is getting very interesting. You see where the I comes from? I'm only using the I because I know that I squared is the same thing as -1, and -1 times this negative will take me back to a positive, so I've not changed the meaning. The reason I'm doing that is because I want to form factors using a difference of squares, because at this stage x minus half squared is a square, and then I can express this as 2 whole numbers. 3/4 is the same as 8, 11/4, 11/4 squared I all under square root close brackets. Still, this does not change the meaning. Yeah, it does. Wait. That is the square root of 11/4 squared times I squared. That doesn't change the meaning. So then my factors would be x plus 1, x minus half minus one of these, so the square root of 11 over 2I, and the other one would be x minus half plus square root of 11 over 2 times I. So those are my 3 factors. Now I realize that starting here going onwards, I've confused you with the type of approach that I decided to use on this, because I'm infatuated with completing squares. But If you wanted to do it much faster, x squared minus x plus 3, if I can use the quadratic formula. If I set this equals 0, I can use the quadratic formula. X is equal to negative b is negative 1, so that's negative 1, plus minus b squared minus 4 times 1 times 3 divided by 2. So that's positive 1 plus minus 1. This is 1 squared is 1. Negative 4 times 1 times 3 is negative 12. 1 minus 12 is negative 11 square root all over 2. So I end up with 1 plus minus the square root of negative 11 is the same as I root 11 divided by 2. So by doing this, I get the solutions, and when I have the solutions, it can help me to get the factors. So if I break this down, I hope you can see that x is equal to 1 over 2 plus minus I root 11 over 2, which means that the two factors, if I try to get the two factors, I'm going to do that by taking the half on that side. I have x minus half is equal to x minus half, minus I root 11 over 2 as one of the factors, and the other factor would be x again minus half plus I root 11 out of 2, which are the same two factors that I got here. Just went a longer way to get them. So that's one way that's how you could use this graph of the third degree polynomial, straight line third degree polynomial, and the factor given to factorize, to write the factored form of the polynomial. If you want to simplify this, you can go ahead. This would be 2x minus 1, and I know you might not be interested, but you can go ahead and simplify this if you want to. Alright, hopefully the last one or second to last. Use the given volume of a box and its length and width to express the height of the box algebraically. So I've been given the volume. I know volume is length times width times height. Now I've been given the volume, I've been given the length and the width, and I want the height. I hope you can see that height is the same thing as volume divided by length times width. So I need to first figure out what this is, and then simply divide the volume by the combination of these two. So if the length is 3x minus 4 and the width is also 3x minus 4, then length times width is 3x minus 4 squared, which simplifies to 9x squared minus 3 times 4 is 12 times 2, 24x plus 16. So I want to divide the volume by this expression, which is length times width. So I start my long division. The divisor is 9x squared minus 24x plus 16. The dividend is the expression for volume, which is x cubed minus 21x squared minus 40x plus 48. So let's do this quickly. 18x cubed divided by 9x squared. 18 by 9 is 2x cubed by x squared is just x. So then go backwards, multiply 2x times 9x squared is 18x cubed. 2x times 24x is negative 48x. And 2x times 16 is 32x. Sorry, 2x times 24 is, this is x squared. And 2x times 16 is 32x positive. Subtract 0, negative 21 minus negative 48, that is positive 4 minus 2 is 2, 8 minus 1 is 7, positive 27x squared. Negative 40x minus 32x, that's negative 72x. And then finally plus 48, because this just comes down here, because there was 0 here. 27x squared divided by 9x squared. 27 and 9 is 3. X squared and x squared is just x squared. I mean just 1, so there's no x. So, yeah. 3 times 9x squared is 27x squared. 3 times 24x is 72x. And 3 times 16 is 48. So when I subtract this, I end up with zeros, zeros, zeros. So that shows you that what I have at the top has to be the height of this box. So the height of the box is 2x plus 3. Okay. Yeah, so this is an approach. Think of another way to do this problem. Can you think of another way to do this problem? You guys let me know if you can think of another way to do this problem. This is your homework. Enjoy.